Hey guys, I just got my hands on the 2025 Methods Exam 1. I heard that it was okay, but just a bit long, so let's see. So the first one is differentiate using the product rule, so that would be 2x cos x minus x squared sine x. This one is to find the tangent at x equals 8. So f dash x will be 3x plus 1 to the power of negative a half, and then f dash 8 will be 3 over root 9, which is 3 over 3, which is 1. Let g of x be a function defined for x is greater than negative 3 over 2, so that's the derivative, and g of 1 is 0. We want to find g of x. So g of x will be the antiderivative of 1 over 2x plus 3 dx. Now you need 2 on the top, so you can put a half on the outside. And so that would be 1/2. However, they told you that x is greater than negative 3 over 2, so that basically means that we've only got the right branch of the log, which means we don't need the absolute value. And then we can plug in g of 1 is and then you can say g of x is equal to 1/2 ln, and you can combine the logs to have 2x plus 3 on 5. State the range of f for a cos graph. So it'll be the mean position plus 2, so 1 plus 2, which is 3, and the mean position minus 2, which will be negative 1, so negative 1 to 3. Solve f of x equals 0. So basically, cos 2x equals negative 1/2. The domain is x is an element of 0 to 2 pi. That means 2x is an element of 0 to 4 pi. And cos is equal to negative a half in the second and third quadrants. And we are going to 4 pi like that. So we've got 2x is equal to pi minus pi on 3, which is 2 pi on 3, pi plus, which is 4 pi on 3. So that gives us those two, and you can add 2 pi to both. So add 6 pi on 3 would give 8 pi on 3 and 10 pi on 3. 2 pi on 3, 4 pi on 3, 5 pi on 3. So that would be those. And then sketch for x is an element of pi over 2 to 3 pi over 2. So, and label the endpoints. So we can just plug in pi over 2. So pi over 2 will give cos of pi, which is negative 1. And then times 2 is negative 2, plus 1. So yeah, that would be negative 2 plus 1, which is negative 1, which is the minimum. And then 3 pi over 2, I think will be the same. So cos of 3 pi is negative 1 times 2 is negative 1. Negative 2 plus 1 is negative 1. So that would be over here. So that's at the lowest points. And so basically, if we're starting from the lowest point, you can kind of think about that the graph will start at 3, and then at pi it will end at 3, and then it will be at the mean position halfway in between. So that will be here and here, and then here as well. So we basically just want this part. And then it just says label the endpoints. It doesn't say we need the x endpoints. So that will be and 3 pi over 2, negative 1. You can also say these x-intercepts are going to be the two between pi over 2 and 3 pi over 2, so those. Show that k is 10 or k is 15. So all of these added together. So 2k on 75 plus k on 75 will give 3k on 75. Plus 2k, so that would be 6 over k. That's equal to 1. And then 3k on 75. You can also simplify that to be k on 25 is equal to 1 minus 6 over k, which is k minus 6 over k. And then you can cross multiply. Equals 25k minus, and then 6 times 25 would be 150. And then k squared minus 25k plus 150 equals 0. And you can use the clue that it's going to be 10 or 15. So those are going to be the two numbers that you try and factorize with. And they will both be negative to add up to negative 25. So k minus 15, k minus 10 equals 0. K is equal to 15 or k is equal to 10. If k is 15, find the probability that x is greater than 1. That just means these two. So it will be 15 on 75 plus 2 on 15. And 15 times 5 is 75. So 15 plus 10 on 75, which is 25 on 75, which is 1/3. Find the expected value also with k is 15. So it will be, this will go, and you'll have 30 on 75 plus 2 times 15 on 75, or again 30 on 75, and then plus 6 on 15. So that would be plus, again, that would be 30 on 75, which is 90 on 75, and you can divide by, we'll start off with 5. $18 on 15, and then that will be 6 on 5. Solve e to the power of 2x minus 8e to the x plus 7 equals 0. So you can basically say that this is e to the x squared, and then you can say 7, 1, e to the x, e to the x. You can also let a be e to the x or something, but both are negative. So e to the power of x minus 7, e to the power of x minus 1 equals 0, e to the power of x equals 7, e to the power of x equals 1, x equals ln 7, x equals 0. Let g of x equal that, where x is an element of all real values. The function g has exactly one stationary point, which is a local minimum. Find the largest value of a, such that when g is restricted to the domain, it has an inverse function. So if it has one stationary point and it's a local minimum, we basically need to solve for that minimum. Now, because this is technically like a quadratic, you could probably just say that the minimum happens when e of x is equal to negative b over 2a, because the minimum would happen like x is negative b over 2a. So you can say a or 4 when e to the power of x is 4. And so you can say that the domain should be negative infinity to ln 4. Oh, so a is ln. But I probably just want to check that. So differentiate, that'll be 2e to the 2x, and then minus 8e to the x, and solve equal to 0. And you will have, if you take e to the x as a common factor, 2e to the x, the x minus 4 equals 0. And yeah, so this one goes, and then we have e to the x equals 4. So yeah, you can use the fact that this is kind of like a quadratic. It's like a squared minus 8a plus 7. And then you can say that the minimum of this happens when a is negative b over 2a. So when e to the power of x is 4. Find the variance of the binomial. So the variance of a binomial is n times p times 1 minus p, which will be, that's 2, that's 3, so 9 on 8. Yeah. Determine the probability that x is greater than or equal to 5. So that means we have to use the formula for 6 choose 5. And then 3/4 to the power of 1 plus 6 choose 6, 1/4 to the power of 6, and 3/4 to the power of 0. So this is 6 times, you can basically say 1/4 to the power of 5, and then times by 3. So that will be 18. 1/4 to the power of 6, there's another one. So the 4, 4, 5, 1, those make 4 to the power of 6. And then the 1 to the power of 6 is just going to be 1. So it's 1 over 4 to the power of 6. And then plus, this is 1, and then another 1 on 4 to the power of 6. So you can take that as a common factor, which is 19 on 4 to the power of 6. Now you can technically say this is 2 squared to the power of 6, and say that's 19 over 2 to the power of 12. So either this or this will be fine in this case, because both of them, actually, sorry, no, it says 2 to the power of something, so it's just that. Verify that x is 5 is a solution. So 5 cubed minus 5 squared minus 16 times 5 minus 20 equals 0. 5 cubed is 125 minus 25 minus 80 minus 20 equals 0. 100 minus 100 equals 0. Therefore, x equals 5 is a solution. Express f of x in that form then. So now that we know that x equals 5 is a solution, then x minus 5 is a factor. So you can basically just do long division and say minus x squared minus 16x minus 20. And then you'll have x squared, x cubed minus 5x squared, subtract. And you have negative x squared plus 5x squared, which is 4x squared minus 16x. And then plus 4x, so 4x squared minus 20x, subtract, and you have 4x minus 20. And that will give you plus 4, and so you'll have 4x minus 20, which is 0. Therefore, you can say that it's x minus 5, x squared plus 4x plus 4. And so f of x is equal to x plus 5 and then x plus 2 squared. Consider the graph of y equals f of x as shown. Complete the coordinates pairs of all the x-intercepts or axis-intercepts. So this one here is going to have a negative 2 and a negative 5. What have I done? Sorry, it was x minus 5. Why did I write plus? So 5 and negative 2. And that's a turning point, which is correct. And then the y-intercept we just need. So the y-intercept we can just use the original form, which is negative 20. So let g of x equal x plus 2. State the coordinates of the stationary point. So that will basically mean that you have x minus 5 and then x plus 2 cubed. So that's the stationary point. And they want the full coordinates, so it will be negative 2, 0. write down the values of x for which f of x times g of x is greater than or equal to 0. So we know that the graph will look like, and we'll have that same x-intercept and the 5 as well, but now it will look like this. That's because it's now a power of 4, it will start at the top and finish at the top. So it will be greater than or equal to 0 for x is an element of negative infinity to negative 2 union 5 to infinity. Okay. This continuous random variable x has a probability density function f of x. Find k such that the probability that x is greater than k is equal to 9 on 16. So the integral from k up until 4 on 3 of... this is a... I probably wouldn't use a integral for this because this is a straight line. So you can probably use a triangle or trapezium. If you just draw it out, it will start at the point when you plug in 0, it will start at 3 over 2. And it will end at 0. So it basically looks like this. And from k upwards, you basically have a triangle. So this, the height would be, it would be half times 4 over 3 minus k, and then times the y value at k, which is just going to be 3 over 8, 4 minus 3k. That's equal to 9 on 16. Now, what you can do is combine these. So you'll say 3 on 16, 4 over 3 minus k, times 4 minus 3k is equal to 9 on 16. Now, what you can do is you can put that 3 on the inside to make it 4 minus 3k, which would make this squared, and 1 on 16. So, and then the 16 you can cancel. You can say 4 minus 3k squared equals 9. And then 4 minus 3k is equal to 3 or negative 3. And then 3k is equal to 1. K is 1/3. Or 3k is equal to 7. K is equal to 7/3. And then you probably have to reject one. So 7/3 would go because that's outside of the domain. So k is 1/3. The function h of x is a transformation of f of x such that we have this. Find the integral from 0 to 4/3 of h of x in terms of m and n. So the integral from 4/3 of m and n, of f of x, is equal to 1 because it's just the integral of a probability density function. So you can say the integral from 0 to 4/3 of f of x dx is 1. Therefore, the integral from 0 to 4/3 of h of x, which is plus n dx, is equal to m times the integral from 0 to 4/3 of f of x dx plus the integral from 0 to 4/3 of n dx, which is m times 1 plus, this will be 4/3 n. Consider the functions, those two functions. W is all real values. If w equals negative 3, find the 4 solutions to f of x equals g of x. So negative 3 squared is 9 over x minus 1 squared equals x plus 3 squared. Right? Yeah. Now, here you can say x plus 3 squared times x minus 1 squared equals 9. Now here, this is going to be, you could technically move the 9 over and do 3, like minus 3 squared, and then put it within. However, you can realize that this a squared times b squared is the same as ab all squared. So you can say that all squared equals 9, and then you can plus 3 x minus 1 is equal to plus or minus 3, right? So you've got 2 there, and you should get 2 here and 2 here, and that would be 4 solutions. So this will be x squared and that will be equals 0. This will be I don't think you can factorize that. Yeah. So we can say the square root of 4 plus 24 over 2 x equal to negative 2 plus or minus root 28. You can take out 2 root 7 over 2. X is equal to negative 1 plus or minus root 7. And then for this one, you can say x squared plus 2x minus 3 equals negative 3. X squared plus 2x equals 0. X plus 2 equals 0. X equals 0 or negative 2. So these are the 4 solutions. Consider the case where w is greater than 0. Find in terms of w the coordinates of the minimum point of the graph. So the minimum point is halfway in between the x-intercepts. And so the minimum point would be, if you've got like 1, 0 and w 0, it would just be 1 plus w over 2. And then you've just got to plug that in to find the y value. So 1 plus w over 2 minus 2 over 2, so minus 2, would be w minus 1 over 2. And then times by w plus 1 over 2 minus 2w. So that will be negative w plus 1 over 2. So the coordinates will be 1 plus w over 2. And then I'm going to take a negative out of that and say negative, and then w minus 1 squared over 4. I hope that's right. Hence or otherwise find the positive values of w for which f of x equals g of x has exactly 3 solutions. Okay, so I just want to write f of x and g of x again. F of x equals w squared over x minus 1 squared, and g of x is equal to x minus w squared. Hence or otherwise, find the positive values of w for which f of x equals g of x has exactly 3 solutions. So we will basically be solving times x minus 1 squared is equal to w squared. Now that's why they've given us this. because we can basically say x squared is equal to w squared, and x minus w, x minus 1 is equal to plus or minus w. So that, or x minus w, x minus 1 is equal to negative w. Now, we know that the minimum... Okay, we can draw this out. We know that w is positive, so that means both of the intercepts are here. This is 1 and this is 2, or it could be the other way around. And the minimum is definitely negative. So it's like this. And equal to w would be like this. Sorry, it would be like somewhere here. This one you would have the same thing, but you want that to be over here so that you have 1, 2, 3 solutions. You want it to be at the minimum. So you basically want negative w to be the same as this, is what we're solving. So negative w minus 1 squared over 4 equals negative w. Squared is equal to 4w. Yeah, and then w squared minus 2w plus 1 equals 4w. W squared minus 6w plus 1 equals 0. And I think, again, we're going to need to use the quadratic formula. So w is equal to 6 plus or minus square root of 36 minus 4, which is 32 over 2. W is equal to 6 plus or minus 2, what's that? You can do 16 times 2, so 4 root 2 over 2. W is equal to 3 plus or minus 2 root 2. Yeah, and it says positive values, so that tells you that there's 2, so W, yeah, those 2 I think would be the answers. And that's it. So I think that was a really good but tricky last question. I hope I did that right. I'll just make sure. Yeah, I think so. So that was the exam 1. I think it was all right. You just had to work a bit quickly to make it through. But yeah, I hope everyone did well.